So my name is Brandon Dodd. I'll be talking to you about the ethane cracking process in Tennessee. What we'll be doing is I'll give a brief overlay of what ethane cracking is. I'll talk about what has been completed regarding the ethane cracking project we're working on this semester, what has yet to be done, and what skills are needed to perform this. Ethane cracking is when you take an ethane feedstock and you feed it into a furnace along with some steam. You heat it up to approximately 850 degrees Celsius. And you do this in the presence of a catalyst. And this allows it to free hydrogen, which then forms hydrogen gas. And this produces mostly ethylene, but you do tend to break down into some methane radicals, which can then reform and create propylene and butadiene and all kinds of other interesting hydrocarbons. From this point, the feed is rapidly quenched and cooled through a series of heat exchangers, and it's fed into caustic towers and compressed, and eventually sent off to distillation so you can separate out what you want. So far for the project, done research on what ethane cracking process is, because initially I had absolutely no idea. Looked up process flow diagrams, and then I performed material balances, particularly on the furnace. This is a process flow diagram. I couldn't really break it up, but as you can see off the left-hand side, two streams come in. The stream merges with ethane, goes into a furnace, and then it goes to a transfer line exchanger, and that's where it starts the quenching process. And then it goes into a quench tower where it's cooled. It gets compressed up to a pretty high compression rate, goes into a caustic tower, and then goes into a acetylene container or acetylene converter. It's compressed, and then basically goes to refrigeration and out to distillation columns. I did material balances for the steam cracker stuff. This is the initial furnace. I used a basis of 500,000 tons per year, and used the assumption that steam doesn't react, and that full cracking of ethane happens. You can see you got a feed stream of ethane coming in, steam coming in, steam coming out, and then all kinds of other stuff coming out. I don't actually have the numbers for what I got on this, but I think I came to something like 48% ethylene coming out. What I need to do, there's still a lot of material balances to be worked on. We need to do material balances for all the individual pieces of equipment, and along with energy balances, because you have a lot of pieces of equipment in place. You have compressors and towers and heat exchangers, so you need to figure out what all those need to do. And what skills are needed? Obviously, knowledge and background in various engineering topics. And you need to have the ability and skills to use various material software and how to use your research mediums. But most importantly, you need an enthusiasm to learn and develop.